Given the root of a binary tree and two distinct nodes P and Q, with unique values. The twist versus the usual LCA problem, P or Q might not exist in the tree. Return their lowest common ancestor only when both appear, otherwise return null. Constraints, up to 10 to the fourth nodes, unique values, and P is not Q. Example 1, P is the node with value 5 and Q is the node with value 1. Both are in the tree, under the root 3 in different subtrees, so the lowest common ancestor is 3. Example 2, P is still the node 5, but Q is the value 10, and there is no node 10 in this tree. Because one target is missing, the answer is null, not an LCA inside the tree. In the classic problem you may return as soon as you touch P. Here that is unsafe, Q might sit under P, or Q might be missing entirely. You have to keep walking so every hiding spot is checked before you trust the result. Think of it as a census, not a race to the first hit. Each time the traversal genuinely visits P or Q, tick the counter. Two separate sightings are the proof both nodes live in this tree. When the recursion finishes, look at the census. 2 means both P and Q were really in the tree, so the node you computed is a true lowest common ancestor. If you only logged one target, the pair does not exist here, return null, not a half-baked node. Post-order depth-first search, both subtrees finish before we merge at each node. Here is the walk. That visit is Q. The global target counter moves to 1 of 2. That visit is P. With 2 sightings, the counter reads 2 of 2. Same tree, Q is 10, but no node has value 10. Post-order walk next. We did find P, but Q never appears as a node in this tree, so the counter stays at 1 of 2. The inner merge can still bubble a pointer upward on the way back, yet the final step checks that both targets were visited. Since Q was not, the public answer is null. Let n be the number of nodes and h the height of the binary tree. Time is O of n in the worst case. A single depth-first search visits each node once, with constant time to combine left and right results and to bump a counter when we land on P or Q. Space is O of h for the recursion call stack. Besides that, we only need O of one extra integer space for a sightings counter that goes up to 2. If the tree is skewed, h can be about n, so worst-case stack space is O of n. Function lowest common ancestor 2, we receive the tree root and node references P and Q. A counter tracks how many of P and Q we have actually visited in the tree. Inner depth first search on a node. If the node is null, the subtree contributes nothing. Return null. Recurse on the left child and store the result in left. Recurse on the right child and store the result in right. If the current node is P, increment the counter and return this node. Add 1 to count. Return the current node. If the current node is Q, increment the counter and return this node. Add 1 to count again when needed. Return the current node. If both subtrees return a non-null pointer, this node is the merge point for this frame. Return this node. Otherwise relay whichever side is non-null, or null if neither. Run the inner search from the root and keep the candidate pointer in cand. If the counter reached 2, both targets exist in the tree, so return the candidate. Return cand as the lowest common ancestor. Otherwise at least one target was missing, so return null.